So Michel Buffa is from University Côte d'Azur, France, and he's been the coordinator of a very relevant project in the music domain, and very strongly relevant to what we are doing in Polifonia, which is the Wasabi project. They built a huge knowledge graph integrating information about 2 million commercial songs. And I already have a question for later, because I want to know what kind of agreement and how we can get something like this for the project. And Michel, so he does his research in this domain. And well, so you already said a lot, and I think now it's time to really start.
Okay.
So if you agree, I will notify you when you have used the 20 minutes, and then you can take additional few minutes.
Perfect.
Okay, that's
perfect.
Okay.
That's perfect.
Thank you.
Okay, so the project was called Wasabi, and as you said, it's about building a music knowledge base about 2 million popular commercially released songs, pop, rock, funk, rap, and so on, in multiple languages, but it's mainly English, and all the other languages are distributed, but represent a low percentage. So what we did is that we joined different partners. So there is INRIA. My research team is common to French CNRS and INRIA. We had IRCAM, that is a sort of a very well-known music research lab in France. We had Deezer, that provided all the audio content. Queen Mary University, we partnered with them for the audio analysis of the songs. And we had some other small companies that are not represented here that have done some part of the work. So the project ended in 2020, but is still alive. Not in the same form, but we have 2 PhDs working actively on the follow-up of the project, and we are still developing client apps and updating the data sets and so on. So it was a huge project that lasted for 3.5 years. And the goals were to build a 2 million song database with cultural metadata from music data source on the web. So get the web of data, get everything you can about the most popular songs of music history, I mean commercial songs. So we've got all the Beatles, Elvis Presley, Rolling Stones, Guns N' Roses, Deep Purple, and so on. But we wanted to get what I call multicultural metadata. Is the metadata from Wikipedia, from Music Brands, from Last.fm, from different data sources that with different formats. So we aggregated them and we merged all this metadata. Then we also collected the song lyrics. In fact, we started from there because we wanted to perform a lyric analysis. So what are the songs talking about? What is the structure of the song? What emotions they convey? Are there famous people seated in the lyrics, famous locations, famous events? So what is the topic of the song, and so on. We wanted also to work on the audio. So we had partners that are specialized in audio. So we conducted some audio analysis on the song, on the signal, like computing the chords, computing the key, computing the tempo, etc., etc. And now we are really still working on this part, especially for use cases that implies a musicologist. So we are publishing a paper right now about an analysis of discographies by David Bowie discographies, Queen discographies, analysis every cultural metadata like collaborations, influences, and so on, but also go deep into the signal and look at the timbre analysis, why is this song sounding like that, and so on. So we are multi-scale. We are providing multi-scale data to go from the very top level data, like when has this song been recorded, to show me the signal and explain to me what is the variation of the volume over the time and so on. So also we wanted to link semantics. So the dataset is a dataset, in RDF dataset that is using RDF vocabularies. We added to the dataset some results from the audio analysis and from the lyrics analysis, but sometimes we used machine learning for doing this analysis, and we are also sharing the models that we computed and some pieces of code if you want to do the computation yourselves. So we had different algorithms that work together. For example, for detecting the structure of a song, we had some original work that mixed the audio analysis of the song, get the structure from the audio, get the structure from the text of the song, from the lyrics, and then match them together in order to reduce the uncertainties and get better results. So this was also a particularity of this project, and the people from Deezer, they developed, the famous splitter tool for separating the different instruments from the songs, for doing source separation. So from an MP3 or from a YouTube video, you can separate up to 5 different tracks with piano, drums, bass, voice, and I think others. So what we wanted to do, but for the moment we didn't have time to do, is trying to analyze separated tracks, not the whole mix, and try to guess more things from them. But this is for perspectives now. And develop and publish open source web services to make people able to consume the data without having to install the dataset on their side. And we developed client applications, some applications for visualization, analysis, audio applications, and release the public dataset. So this presentation was for ESWC 2021. So the focus right now for this presentation is more about the dataset than about the client application. So how did we build the dataset? We started from a now suspended data source called LyricWikia. We started from the lyrics. So we wanted songs with the lyrics. So in 2017, there was a LyricsWikia. So we use it API to grab 1.700 million lyrics from songs. This was a screenshot from this data source that was available at the time. We also get some thousands, 400,000, I think, synchronized lyrics. So that means the lyrics with information about when they are singing in the songs. So this we used for we got them from a karaoke German website called Wimmics, and it was useful for working on the structure analysis of the song. And this is also available. We also get access to the audio content from Deezer and sometimes from YouTube. And we then performed the lyrics analysis, the audio analysis, and we started to get cultural metadata. LyricsWikia had some IDs from music brands, sometimes from Last.fm and so on. So we started, grabbing data. So we developed many different scripts to grab data from more than 20 data sources in different formats. And then we had to merge all these things. So from the lyrics analysis and audio analysis, sometimes we didn't get structured data out of the box. But now we are the recent updates to the dataset from this year, for example, consisted in adding RDF formatted metadata for lyrics analysis and audio analysis. So we got results from the audio analysis, from the lyrics analysis. We got the machine learning models. Then a lot of work has been done for curation. So we had some sort of marathons where a lot of people try to find the errors on the database, on the data set. There are still errors in the data set. And it's the topic of one PhD in our team right now. And then the first thing we did is to build a NoSQL version of the dataset with a REST API for having quickly, user interfaces and being able to work with the data. And then multiple times over the lifetime of the project, we exported and we used what I call the RDF translator that has been developed in the team. We developed vocabularies and we started to align the RDF version of the database. So now the main data source we are using is running on Virtuoso and on a Sparkle endpoint, and you can download the dataset from Zenodo and the scripts that we developed from GitHub. And from these different endpoints, the REST endpoint for very fast, request, like you can type, and at the speed of your typing, you got auto completions and the data that are coming. But for more complex requests, you can use the Sparkle endpoint. And we developed a different kind of applications. So we've got PhD about visualization. We've got some web audio client application for music schools. We've got applications for musicologists and so on. So you can see some early visualizations we did 1 year and a half ago. For example, visualize collaborations among artists. So here you can see the different albums by Eminem and the different collaborations. Here I'm going to show you a video that is 6 months old, but now we've got much better result. But this one uses some tools we have developed for requesting in Sparkle the endpoint and do some visualization. So it's my PhD student that is talking.
From a list of predefined Sparkle queries, we can launch a visualization technique to see the results. Here we have the artists that used the word love in the title of a song from 2010 to 2020. From an artist, let's say Max Martin, we can see all his collaborators and the songs he created with another artist. As we shall see, every song is connected to the Wasabi RDF graph. We can also see the collaborations among artists as clusters, as shown here.
Okay, so this is just a very preliminary work by my PhD student.
From a list.
Sorry. The lyrics analysis is also available. The machine learning models are available, and everything is provided on the GitHub from the project, where you can download the Wasabi dataset, but also all the applications we developed for grabbing the data and so on. And we published some paper, especially on the topic of lyrics analysis. So I'll talk later about the copyright that are the copyrighted data. So we worked a lot with copyrighted data, so we can share them under certain conditions for scientific collaborations, for example. We'll talk about this a bit later. So from the lyrics analysis, here are some interactive examples from the user interface of the NoSQL database. You can visualize very quickly, the structure of a song with the self-similarity matrix and the verse and chorus and so on. You can see also the different topics. So here's a tag cloud of some of the songs. We've got also, we tagged using machine learning models the explicitness of the lyric content. So does this song contain offensive words for children and so on. We also perform some sort of automatic thumbnailing of a song, text thumbnailing. So we reduce the lyrics down to 4 sentences or 2 sentences using some also machine learning techniques, and we use some techniques similar to audio thumbnailing when you want to reduce a song to a few seconds, for example. I didn't work on this particular topic. It's Elena Cabrillo, so I won't be able to explain and give too much detail. I'm sorry. And also, we used the Last.fm. We grabbed the Last.fm tags about emotions. So you've got also a classification of the songs in terms of with a BERT plan with the different emotions, and you can locate the different songs, on this map. What we can do with the lyrics metadata, we could see, for example, the evolution of topic importance about war, death, love, family, money, religion over decades. So you see that nowadays death is much more popular than love. That was popular in the 60s and 70s. Evolution of explicit content of the lyrics. Well, today, a lot of rude words in the lyrics, much more than in the 70s. And you can see also the topic importance in David Bowie songs over time, for example. And the death was a big preoccupation for him in the late years, for example. For the audio analysis, the first things we had was the tempo, and the chord extraction. So we extracted chords from more than 5,000 songs, because after that, Deezer said, "Okay, you're taking too much CPU on our VMs." So we have an agreement to perform, to complete this chord analysis. So normally we should get up to 1,200,000 songs with chords this year. Some experimentations are scheduled for the next quarter. And we had an augmented audio player where you can play songs from the user interface of the NoSQL database, and you could see during the playing the different chords appearing. We have also a search engine for songs that contain particular chords or particular sequence of chords. And you can also look for different keys, the song. But what you must understand is that dataset has been enriched by audio content analysis. So the songs have been computed and represented in RDF using some standard representation. So we use some well-known ontologies that we have a little bit simplified. So everything is consistent among the dataset. All the songs that have chords are consistent. And we also provide a confidence measure. So this work has been done by some researcher from Queen Mary University on our datasets. And they shared the Wasabi identifiers for the songs that we are also aligned with Deezer identifiers and with YouTube identifiers. For more on-the-fly, on-demand audio analysis, we are using an API called TimeSide that is located at IRCAM. So we can give them Wasabi IDs, and they will get the songs from Deezer or from YouTube. And then we can use a user interface, but also an API. You can do this programmatically and ask for different computations, so they can compute something like 160 different audio analyses. They have all the VAMPs plugins from Queen Mary University, for example, and then you can once you computed some analysis, the result can be stored and available immediately. So such a graphics here, you don't have to recompute them every time. But this is more for an on-demand. I have a song, I want to perform a given analysis. I am a musicologist and I have an account on TimeSide, and I can keep track of this the next time I'm coming back and so on. So we are using such tool now for analyzing discographies. We are providing the dataset from Zenodo. We followed all the good practices for publishing a semantic dataset. So as you can see, it's a reference on the Load Cloud and so on. We have an online Sparkle endpoint, so you can try it on the Wasabi inria.fr Sparkle URL. We've got some new tools that are not linked here, but where you can run visualizations and things like that. And an exhaustive documentation on GitHub with all the script tools. I'm saying exhaustive, not easy to understand, because we developed a lot of software for this project. So the dataset is okay, but I'm not guaranteeing that all the scripts written 3 or 4 years ago for grabbing the content, for grabbing the metadata from, say, DBpedia, Music Brands are still up to date. Okay, so the status of the dataset is here. We have 2 ongoing PhD theses, one about visualization and quality control of the dataset, and another one is developing music instrument for sonification of the semantic data. And we are on the way for submitting a follow-up to the Wasabi project that will continue the work on this dataset. Privately available, contact us, are the fully timed chord sequences synchronized with audio. On the public dataset, you've got all the chords present in a song, but not with the time, when they start, when they end, and so on, because it can be considered as a violation of copyright. We can also provide the full-length lyrics. So for the moment, it's only available just a 10% extract of the lyrics. Recently, we added all the results from the lyrics analysis, topics, structure, segmentation, and so on. As RDF, we developed the vocabularies for that, and we submitted a paper to a journal with details. So, for example, you can find explicitness of the lyrics, you can find the different terms used in the title, and so on. So you've got represented as a tag cloud, you've got the topics and so on. So everything is now available as RDF, and we are still extending this. For example, the recent results from the audio analysis, if we want to be able to make them if we want to make them requestable using Sparkle, we are going to add some vocabularies for that.
Michel, just to tell you that you used
okay.
20 minutes.
I've got it's the last slide.
No,
so the next,
okay. I mean, it's so interesting. So we all want to know.
So what we are doing right now we are performing timbre analysis. We've got musicologists working with us that are helping us analyzing discographies. So we got a paper about Queen and David Bowie discography analysis. And as I said, we are going to add more chords. And we have a PhD about visualization. It's a multidimensional audio and graphics visualization from the dataset. And for this, we developed different tools. So the tool you saw in the video is called MG Explorer. So we developed many more visualizations and annotation tools that we added to annotate the visualizations and so on. Thank you for your attention. Okay. Yeah, I've got a last slide if you are curious. Wasabi has 2 million songs because the previous biggest dataset was 1 million songs. And with some friends, some researcher friends, we were at a conference in Italy, in Florenza, and we drank too many beers, and we decided to make a project that would be twice bigger than the previous existing one. So this is why we started with the 2 million target in mind. I'm finished. I have finished. So if you've got questions.
Thank you so much, Michel. And I'm pretty sure there will be many questions. Actually, while we